In this video, we're going to use a 16x16 LED matrix to display images using the ESP8266. We're going to use what we learned in a different video for uploading the files over HTTP. We're going to change things around so that we can grab the files, drag and drop them using the browser, and display them on the LED matrix. Alright, let's do this. This video is sponsored by LCSC Electronics. Using your favorite CAD program, you can simply export the bill of materials and use the BOM tool built into their website to get the components you need for your design. They'll help you even find components out of stock, they'll ship it for very cheap, and they have great facilities, wonderful people, so I highly recommend LCSC Electronics. As usual, I'll download the repository of all the pieces of code we've developed in this series. I'll make a copy on my desktop of the web server HTTP upload that we created in a different video. I'll rename it to JPEG WS2812, which is the LEDs that we're going to be controlling. I'll make a couple of changes for my network ID and password so that I can connect to the internet. I'm going to be using the NodeMCU DevKit 1.0 development board for the ESP8266 and a WS2812 LED matrix of 16x16 pixel size. You can get these components on my little Amazon shop. Using jumper wires, I'll use the JST connector on the LED matrix and a breadboard to make the connections. I'll start with the red wire, which I'll connect to 3.3 volts. Next, the white wire out of the matrix I'll connect to ground. And lastly, the data signal, the green wire, I'll connect to pin D4 on the development board. Making sure that the USB drivers are installed as we've done in other videos, I'll select the corresponding option from the tools menu for both the board and the port. I'll upload the code that we already had, and the change I'm going to make is uploading a new index file so that we can drag and drop files onto the browser. As I want to focus on the firmware running on ESP8266, I'll briefly go over the contents of this file. It includes some styling for things to display nicely, a block of HTML that control the actual elements in the page, but where most of the action happens is in the JavaScript side of things. We're using JavaScript to monitor when the files are hovering or drop over the page, and then an AJAX request, which we've done in other videos, gets sent to the URL /upload in order to send the files over HTTP to the ESP8266. So if we go back to the Arduino IDE and get the IP address of the ESP8266 and then replace this new index file for the old one we were using, we can go onto the terminal and use the curl command in order to upload the file to the flash memory of the chip. Once we do that, we can go onto the browser, navigate to the IP address, and see the file in action. Now, instead of using the terminal, we can simply drag and drop the files onto the browser, and if we visit the other route we created, we can see that new files appear in flash memory. Once that's done, we can focus on displaying images on the LED matrix we connected to the chip. To do that, we'll need a couple of libraries. The JPEG decoder library to decode the images we're going to be uploading, and the Adafruit NeoPixel library for controlling the LED matrix. We'll include the JPEG decoder library and use a define statement to avoid some conflicts that this library creates with the file system library. We'll also include the NeoPixel library But because the matrix I'm using has a different arrangement, we're going to do a remapping of the pixels from one to the other. We'll then create an instance of the NeoPixel object that we'll use to control the LED matrix. Next, I'm going to get rid of how we were handling the serving of the index page. Instead, I'm going to use a function that I'll name handleFileRead in order to monitor whenever a file is requested. If the file is found, I'm going to display it on the browser, but if the file is not found, I'm going to return a 404 not found error. This function, of course, needs to return a Boolean value depending whether the file is found or not on flash memory. It takes an argument with the path to the file. A bit of a hack, but we know that when that path ends in a /, the request calls for the index file. For other requests, we can simply look at the extension of the file that is being requested and serve it accordingly. I'm going to use another function that I'll call getContentType, give it the path in order to get what type of file is being requested. For this example, I'll just worry about either HTML files or JPEG images. The function will return the type of content that should be served depending on each case. The next thing is to see if the file actually exists in flash memory. And if the type of content is of JPEG type, then we want to send that file to be displayed on the LED matrix. I'll define a function called displayJPEGMatrix that gets called in that case. In addition to displaying it on the LED matrix, I want to visualize the file on the browser, so I'm going to use the streamFile method of the server object to do so. I'll close the file and return true so that a 404 message is not sent to the client. But if the file isn't found in flash memory, then I'll return false. The last thing before testing the code that we have is avoiding conflicts between the JPEG decoder library and the file system library. To do that, we need to use the FS namespace for every call onto the file system library. After doing that, we're finally ready to test things out. We can upload the code, and if we add the path to the file we already uploaded to flash memory, we should be able to see it in the browser because of the FileStream method that's being used on files with the extension JPEG. Also, if we go to the serial monitor, we'll see that the displayJPEGMatrix function was called. Now, instead of printing that message, we can modify the code to send the image pixels onto the LED matrix. To do that, we'll use the JPEGDEC built-in object and a few of its methods. The process involves going through all the pixels in the image and extracting the red, green, blue values so that we can send them to the pixels on the LED matrix. For each pixel, some bits correspond to blue, some bits correspond to green, and some of them correspond to red. In addition to extracting the red, green, blue values of the pixels, we need to know where in the matrix they should be displayed. We can get a column and row values from the image and then use our remapping to send that information to the physical LED in the appropriate position. Before sending those values to the position in the matrix, we need to initialize the communication. As the matrix LEDs are bright, I'm just gonna set down the brightness so that it can be recorded appropriately. And I'll call the show method in the setup function so that they're set to off once the code starts running. I can finally use the set pixel color method with the correct X and Y values of the pixel, as well as the color that we extracted from the JPEG image. We can upload the code. Keep in mind that this function is going to be called when we access the files in flash memory. So if we refresh the page for the image that's already in flash memory, we can see it being sent to the LED matrix. Then if we go back to the index and drag and drop a different file, let's try this green 16x16 matrix. Once we access it, we can once again see it displayed on the matrix. The last image I'll try is one of our favorite video game characters that once again when it's accessed, it's sent to the matrix. The last thing I want to go over is how to easily delete the files once they're in flash memory. To do that, I'll create a new route that I'll call delete, and notice that the method will be HTTP delete. It'll call a function that I'll define called handle file delete, and that'll simply use the SPIFFS object to delete the file from flash memory. I'll pass the name of the file as an argument in the URL of the request. So we need to check that an actual argument was given inside that request. We'll prevent the user from accidentally deleting the top root path. Then we'll check if the file actually exists in flash memory. If it doesn't, we need to send back a 404, and if it does, then we'll delete it from flash memory and send down a message saying which file was deleted to the client making the request. We can upload the code. Now, if we go back to the terminal and use the curl command with different parameters, we can delete any of the files that we uploaded to flash memory. I'll use the blue 16x16 matrix as an example. I get the correct message in response, and if I refresh the list route that shows me all the files in flash memory, I see that the blue.jpg file is no longer there. If I tried for the green.jpg file, it'll also be gone once I refresh that page. So there you have it. We have a piece of code that allows us to upload files to the ESP8266 using drag and drop onto the browser. If those files are JPEGs, we can display them on an LED matrix. If you like my videos, I invite you to my Patreon page where you can chip in a buck or two. That really helps me put in more time into the videos and release them quicker. But whatever you do, don't forget to like, subscribe, or leave me a comment. You can also interact with me on social media. I'm on Instagram, Twitter, and Facebook, and you can even use the community tab of the channel. Thank you for watching my videos, and I will see you next time.